Hello and welcome everyone. Good evening, good evening. I hope I'm audible to you people. So today we are going to cover motion in a plane. We have covered motion in a plane in our batch in detail. So here we'll be just quickly going through all the topics, different type of questions that are asked here in motion in a plane. So let us begin our discussion. Hello Shiva, hello Hari. Let us begin the discussion. First of all, till now, motion in a straight line we have discussed. Now, motion in a plane means the particle or an object is moving in two dimensions, along x-axis also, along y-axis also. Okay, so here we will be studying the motion separately. Let us take the plane is xy plane. So you will study separately along x-axis, study separately along y-axis, or it is xz, then along those two axes, like that. Okay. So if I say talk about the position in this case, motion in a plane. So for position, we will denote position by position vector. This is, let us take x-axis, this is my y-axis, and particle is somewhat here. You can take at some point, let us take x comma y. Okay, so here I will define a position vector. This is my position vector. So when I write position of this, okay, so that will become like xi cap plus yj cap. Like that we will denote. So here we will say these many units along x-axis, these many units along y-axis. Hello, good evening. Okay. Now, if this is the position, this is how we define the position. Now in 3D if you talk about, then we will write it as xi cap, yj cap, zk cap, like this. Okay. Now displacement. Displacement is change in position. When I write displacement, displacement we denote with s. Okay, final position minus initial position. So final position vector you will write like x2 I cap plus y2 j cap, like this, minus the initial position vector x1 I cap y1 j cap, like this. When you subtract it, it will be x2 minus x1 I cap plus y2 minus y1 j cap, like this. This became my displacement. Then when you talk about average velocity, that will be displacement divided by time interval. V average, the average velocity, that will be my displacement divided by the time interval r2 minus r1 divided by t2 minus t1. If you talk about instantaneous velocity, that will be dr by dt, rate of change of position. R is your xi cap, yj cap. So when you put it here, it will become dx by dt I cap plus dy by dt j cap. Velocity is having two components. This is x component of the velocity, which we write as vx. This is y component of the velocity, vy. So my v is basically vx I cap plus vy j cap. Okay. Clear? Somebody is mentioning, sir, I am at 0. I haven't started JEE preparation yet. Is it still possible literally at 0? I didn't do units and measurements even. Okay. Now, if you have to start your JEE journey right now, you have to be a bit more serious. That is one thing. If you are very serious, you can do it. Units and measurements you can avoid as of now. Okay, move ahead because that is not required for other chapter. But you have to do mathematical tools, differentiation, integration, vectors. These things you have to do, and then you start your preparation. So leave units and measurements. Do at the end if you will get time. That is not needed. Okay, I hope Yash you got it. So not impossible. It is not impossible. It is very possible, but you have to be really, really strong. If you will just be focused for 1 month, maybe 1 month, and after that 1 month you will say let me leave it again. So then it will not be possible. Just a second, I am getting back. Font size इसका increase कर दो. Okay, now if I talk about average acceleration is equals to change in velocity. So V2 minus V1 divided by T2 minus T1. If I talk about instantaneous acceleration, that will be dV by dt. V you can write as Vx I cap Vy j cap. If you put it here, your acceleration will become dVx by dt I cap plus dVy by dt j cap. This is your x component of acceleration, ax. This is your y component of acceleration, ay. So a is coming as ax I cap plus ay j cap, like this. If z is also there, similarly consider z. Okay. Reply my question. Nilesh is asking. What Nilesh is asking? Can you mention again, Nilesh, what you want to say? Sir, is my 11th half wasted? Yes. I will not say half wasted. If you become serious now, you can, catch that. So don't worry about that. But you have to be serious. Without being serious, you just become serious for 1 month and then again non-serious, it will not work. If you have a habit of that, so leave this decision, I'll say, better. Okay. If you have a habit of you will be serious for some time, again you will become non-serious, so leave it. Do something different. Okay. Hello sir, Manpreet Kaur. Hello Manpreet. Sir, what about about NDA? NDA preparation you can start if you want. What about NDA? Yeah, NDA is easier as compared to JEE. If I talk about only the exam, okay, then SSB and other things are there in NDA that you have to crack. Okay, let us do this question. This is how the x is varying, this is how the y is varying. X coordinate, y coordinate variation is given to us. Now what we need? Initial velocity of particle, its angle from x-axis. Okay, x is varying like this. What will be my Vx? Dx by dt. Vx is dx by dt. Differentiate it, d by dt of 60. So that will become 6. So velocity along x-axis is 6. Okay, what is Vy? Velocity along y-axis, that is dy by dt. What is y? 3t square. So this become 60. This is my Vy. This is Vx, this is Vy. In general, if you have to write the velocity vector, you will write 6 I cap plus 60 j cap. Like this you will write. Now what we need? Initial velocity of the particle. Initial velocity means t is equals to 0. You put t is equals to 0, initial velocity will be 6 I cap. That's all. Okay, so initial velocity becomes 6 I cap. Then angle from the x-axis. What is the angle from the x-axis of 6 I cap? 0 degree. 0 degree. Because it is along x-axis initially. Okay, next acceleration. You differentiate it. I need acceleration. You just differentiate it. When you differentiate, 6 differentiation is 0. So 0 I cap plus 60 differentiation will be 6. So it is 6 j cap. acceleration comes out to be 6g cap. Next is a distance from origin. Okay, this is how x is varying, this is how y is varying. If you need a distance from origin, under root of x square plus y square. That's all. Now put here x as 6t, y as 3t square. This is how the distance from origin will vary. Sir, please say JEE concept most important. No. Right now you are learning the things. So don't go for which is important, which is not important as of now. Learn everything very nicely. Which is important, which is not important, that you have to see when only 30 days of JEE Main is left. 60 days of JEE Main is left. Huh? That time these things are required. Right now prepare everything nicely. Huh? General kinematics and motion in 1D, that means this guy changed the screen. General kinematics and motion in one dimension, that means okay. Our operator is changing the screen. I am not able to read the comments. Sorry guys. Let me do this question for you. The point moves like this. This is a Erodo question. Okay, x is varying like this, y is varying like this. Where a and alpha are positive constant, the equation of the point's trajectory, okay, plot this function. First of all, we need equation of trajectory. Equation of trajectory means you need the relation between x and y. Okay, you need the relation between x and y. Okay, x is varying like this, y is varying like this. What is common? Time. Time you can replace, you can get x and y relation. Okay, what is time? From here you can write time as x by a. Okay, from this equation, if I write time, what is that? X by a. Time is x by a. Put t as x by a in this equation. So y will become a into x by a 1 minus alpha into x by a. That's all. Now you can solve this equation. It's a xy, just you can open the brackets. It's a xy relationship that only we need. The velocity v and acceleration w of the point as a function of time. You need velocity, differentiate it. Okay, so velocity is equals to dx by dt I cap plus dy by dt j cap. Put x and y here. What is x? 80. So d by dt of 80 I cap plus d by dt of 80 into 1 minus alpha t. So if you multiply 80 inside, it will become 80 minus a alpha t square. Okay, you can just write here differentiating. Okay, 80 differentiation will be a, this is a I cap plus this differentiation will become a minus 2a alpha t j cap, like this. We got the velocity. General kinematics and motion in one dimension, that means both straight line and motion plane. Yeah, yes. Kinematics means motion in straight line plus motion in a plane. Motion in a straight line we have covered previously. Now we are covering motion in a plane. Okay, velocity I got as a function of time like this. I need acceleration also. For acceleration, you can differentiate again this velocity. Acceleration they are denoting with W. Huh? So dv by dt. So that is d by dt of v. What is v? A I cap plus this is a into 1 minus 2 alpha t j cap. Okay, now you differentiate it. Differentiation of a is 0. So 0 I cap plus a into 1 differentiation 0 minus 2 alpha j cap. That's all. So this comes out to be minus 2a alpha j cap. This is W. This is my acceleration. I got the acceleration also. Next is the moment t naught at which the velocity vector forms an angle pi by 4 with the acceleration vector. I know the velocity vector, I know the acceleration vector. When these two vectors will be at an angle pi by 4, how to check that? Dot product you can take, you can find cos alpha, cos theta between them, isn't it? Like, and this is my which option? C part. Okay. So I know acceleration, which we are denoting with the W. I know velocity. I need when the angle between them will be pi by 4. How to get that? W dot V is equals to W into V cos of the angle between them theta. So my cos theta is equal to W dot V divided by magnitude of W into magnitude of V. Put theta is equals to pi by 4, you will get T. What is the value of T there? Easy. That's all. Next question. What is asked here? Position of an ant moving in YZ plane is given like this. This is how the position is varying. The magnitude and direction of velocity at t is equals to 1 second is. Okay, I need just the magnitude and direction of velocity. So this is the position. What is velocity? Rate of change of position, ds by dt here. Okay, differentiate it, it will become 40 j cap plus 5 differentiation will be 0, 0 k cap. So my velocity comes out to be 4t j cap. This is the velocity that is coming. I need velocity at t is equals to 1. So put t is equals to 1, 4 j cap. So 4 meter per second along y axis, j cap it is along y axis. Option D. Yes. Good. Chetan. Next, starting from the origin at t is equals to 0 with the initial velocity this is the initial velocity. A particle moves in xy plane with a constant acceleration of this. This is the constant acceleration. At time t, its coordinates are this. X coordinate and y coordinate. The value of t and y naught are respectively. So here the particle is moving with constant acceleration, uniformly accelerated motion. So there are two ways to solve it. Either you write equation separately along x-axis, separately along y-axis, or you can write the equation in the vector form. Let us write the equation in the vector form directly. So I will say S is equals to ut plus half a t square. This is the direct equation in vector form. Now you write here displacement. How the displacement will be written then? Final position of x minus initial position of x 20. Okay. Sorry, where the particle is initially starting from origin. Starting from origin means initially it is at 0 comma 0 and finally it is at 20 comma y naught. So 20 comma 0 I cap plus y naught, y naught j cap. This is the displacement is equal to, what is the initial velocity? Initial velocity is 5 j cap meter per second. So 5 j cap into t, so it will just become 5t j cap, 5t j cap plus half into acceleration. What is acceleration? 10 I cap plus 4 j cap. So 10 I cap plus 4 j cap half a into t square like this. Now both sides you can equate I cap things and j cap things, then you will get your y naught and you will get your t. I need t and y naught. Okay, so let us equate I cap with I cap and j cap with j cap. On the left side I cap is 20, on the right side I cap is 5t square. So 20 comes out to be 5t square. So t is my 2. Clear, I got t as 2. Then on the left side y cap is my y naught, my j cap. Okay, on the right side j cap is 5t plus it will become 2t square. 5t plus 2t square. What is t? T is 2. Put 2 here. 10 plus 2 into 4, 8, 18. So answer comes out to be 2 comma 18. Fourth option. Okay. Good. Next, projectile motion. Now in projectile motion, the particle is projected at a certain angle. We'll observe the motion along x-axis separately, along y-axis separately. We'll write the equation and we can find anything that is asked there. Let us do it quickly. This is my x-axis. This is my y-axis. And a particle is projected. It goes like this. It is projected with some initial velocity u at an angle of theta. This is how the particle is projected. Now you just observe the motion separately along x-axis and separately along y-axis. Okay, let us observe it. I'll write along x-axis and along y-axis. Along x-axis, what is the initial velocity? U cos theta, the horizontal component of this. Okay, so this is u cos theta, initial velocity along x-axis. Along y-axis, what is the initial velocity? U sin theta, the vertical component of this. So along x-axis, the initial velocity is u cos theta. Along y-axis, the initial velocity is u sin theta. Then acceleration along x-axis is 0. Along x-axis, the acceleration is 0. Acceleration is only along y-axis. So acceleration along y-axis, that is in the downward direction g. So minus g. Okay. Then you use v is equals to u plus at along x-axis, along y-axis, and you can write velocities at any time t. Along x-axis, acceleration is 0, so velocity will be constant. So Vx will always be u cos theta. It will not change with the time. Vy is equals to uy plus ay into t. This equation we will use. V is equals to u plus at just along y-axis. So Vy will be equals to, what is uy? U sin theta. U sin theta. Ay is minus gt. This is velocity along y-axis. Okay, we wrote the velocities at any time t. Can you write the position also? Yes, s is equals to ut plus half at square you can use. Now along x-axis, velocity is constant. So if you write x coordinate at any time t, it will be just u cos theta into t. Along y-axis, if you write the y coordinate, s is equals to ut plus half at square. Ut plus half a t square. What is u? U sin theta. T minus half g t square. I wrote the velocities, I wrote the coordinates, position along x-axis and along y-axis. Now at any time t, you can find any of that. If somebody asks you, where will the particle be after 1 second? You put t is equals to 1 second here, you will get x. Put t is equals to 1 second here, you will get your y coordinate. If somebody asks, what will be the velocity at t is equals to 2 second? Put t is equals to 2 here, you will get the velocity along x-axis, that is constant. Put t is equals to 2 here, you will get the velocity along y-axis at any time t. Okay, then. Now let us find the standard things. Standard things means when the particle reaches maximum height. When the particle will reach the maximum height. Okay, when particle will reach maximum height, it is just moving in the x direction because it is at maximum height. It cannot go along y-axis beyond that point. So velocity along y-axis will be 0 at the topmost point. Vy will be 0. Here only particle will be having horizontal velocity. Okay, you put Vy as 0, you will get the time of maximum height. What is Uy? Vy, u sin theta minus gt. If you put this as 0, you will get the time of maximum height that comes out to be u sin theta by g. Okay. At this point, the particle will be at maximum height. If I ask you what that maximum height will be, you put that time in the equation of y. You need that y coordinate, na? You put that. So your maximum height will be u sin theta into t, u sin theta into t. T means time of the maximum height there. So u sin theta by g minus, what is that? Half gt square. So half g t is u sin theta by g square. So h comes out to be u square sin square theta by 2g. This. When you will be back in Arjuna JEE batch, I will not be there now. Okay, I'm not part of Arjuna JEE now. Okay. Good evening, Sanjana. So this is the formula for maximum height I got. Okay, when the particle will cover the complete motion, that is time of flight. The same time it takes to go to the maximum height, same it will take to come back from the maximum height. So time of flight will be twice of maximum height. That will be 2u sin theta by g. What is this horizontal range the particle will cover? Horizontal range will be the distance it covers along x-axis in time of flight. So range will be equal to my horizontal velocity into the time of flight, and that will come out to be u square sin to theta by g. I got the range. Okay. So range is coming out to be u square sin to theta by g. What will be the maximum range? Maximum range will be when this will be maximum. It means sin 2 theta has to be maximum. It means 2 theta has to be 90. Means theta will be 45 degree. And that maximum range will come out to be u square by g. At theta is equals to 45 degree. We know sin 90 plus theta is we know that sin 90 plus theta. What is sin 90 plus theta? That will be cos of theta. Okay. Sin 90 plus theta, that will be equal to sin 90 minus theta. So here I can say that my range will be same when the angles are complementary angles. So if theta 1 plus theta 2 is equal to 90 degree, so I can say that a range will be same for theta 1 and theta 2. Equal range will be there. Either you throw a particle at 60 degree or you throw a particle at 30 degree, range will be same. Maximum height will not be same, but horizontal range will be same. If you throw a particle at 37 degree or 53 degree, the range will be same. You teaching awesome, and we all are missing you in the batch. Thank you for so much love. And yes, as per the management decision, I'm not there in the Arjuna JEE, but yes, you are having Gaurav Tiwari sir now with you people. Okay, so we got the range will be same for complementary angles. Remember that. Okay, and now let us do equation of trajectory. Equation of trajectory. Equation of trajectory means the relation between x and y coordinate, how x and y are changing. So this is how x is changing, this is how y is changing. So what you need to do, just put time here in terms of x in the second equation. Let us do it. My x is u cos theta into t. So t comes out to be x by u cos theta. My y is u sin theta t minus half gt square. Put t there, x by u cos theta. So y is u sin theta into t is x by u cos theta. X by u cos theta minus half g x by u cos theta square. So what it will become? X u is getting cancelled. X tan theta. X tan theta minus half g x square by u square cos square theta. So this relation, x and y relation, this equation we call as equation of trajectory. Okay. Next, okay, we are having some questions on equation of trajectory. Let us do it together. Trajectory of a particle projected from ground is given like this, xy relation. Okay, then what? The maximum height attained by the projectile will be. I know the formula of maximum height. I can say my maximum height is equals to u square sine square theta by 2g. We know this. But I don't know u, I don't know sine theta. How can I solve it? Take help of the equation of trajectory. Compare this equation with the standard equation. Y is x tan theta minus gx square by 2u square cos square theta. This is the standard equation of trajectory. Compare these two. The coefficient with x is 1 here, tan theta. It means tan theta is equals to 1. Okay. Tan theta is equal to 1 means theta is equal to 45 degree. Theta is equal to 45 degree. Then compare this second coefficient 1 by 20. Here it is 1 by 20, here it is this. So I can say 1 by 20 is basically equal to this g by 2 u square cos square theta. Yes. Theta is equals to 45. I can put it here. Yes, you can put it here. From there I can get u. Okay. U and theta I'll get, then I can solve for h. Yes. So 1 by 20 is equals to g I am putting as 10 divided by 2 u square into cos square 45 is 1 by 2. This and this is getting cancelled. U square comes out to be 200. Okay, put u square as 200 there. So it is 200 into sine square 45 divided by 20. So this is 10 there. Sine square 45 1 by 2, 5 meter. 10 into 1 by 2 is 5 meter. How are you, sir? Where are you from? I study physics from Rajvan sir, but you are also teaching well. Oh, good. I'm fine, and I'm from. Right now taking classes from Noida. Okay, so I hope you know me if you are there in the Arjuna JEE batch. If you are not there, Arjuna JEE English, huh? I was there previously. Right now, not. Okay, A is the answer here. Next question, let us read it out. An arrow is thrown in air. Its time of flight is 5 seconds. Range is 200. Determine these things. Standard things these are. Here it is, time of flight is 5 seconds. What is time of flight? 2u sin theta by g. So 2u sin theta by g is my 5. Range is 200. What is range? U square sin to theta by g. This is 200. That's all. Vertical component of the velocity of projection, horizontal component of velocity of projection, maximum height, the angle made with the horizontal. Anyways, from this, what I can say, I can break this and simplify this in a better way actually. If I break sine to theta as 2 sin theta cos theta, what is this? Range. Range is basically my horizontal component into time of flight. This is what we did. This is my time of flight actually. This is my time of flight. You put this time of flight as 5 here. So this will be u cos theta into 5 is 200. So u cos theta comes out to be 40. What is u cos theta? This is the horizontal component of velocity. So horizontal component of velocity, that comes out to be 40. Then I need u sin theta. U sin theta you can find from this equation. Put g as 10. So t into 5. U sin theta is 25. This is my 25. Then maximum height you have to find. Maximum height formula, you know, u square sin square theta by 2g. U sin theta is 25. Okay, so it will become 25 square divided by 2g. That's all. The angle made with the horizontal, when? I think it is asking initial. The initial angle. initial angle made with the horizontal, tan theta is equals to Vy by Vx. What is Vy? Vy comes out to be 25. Vertical component comes out to be 25. And what is Vx? Vx is my 40. So this is 5 into 5, 5 into 8, 5 by 8, tan inverse 5 by 8. Okay. Okay, welcome, Yunish. Next question, let us do it quickly. Galileo writes that for angle of projection of a particle at 45 plus alpha and 45 minus alpha, are these complementary angles? Yes, complementary angles. It means range will be same. Yes, range will be same. It means ratio of the range will be 1:1. That's all what is being asked here. The horizontal ranges described by the projectile will be in this ratio 1:1. A projectile is projected at an angle 30 degree from horizontal with the initial velocity this. Okay, here we are doing JEE Mains PYQs, guys. JEE Mains PYQ, some question I took from Erdo, so it will be a good revision for you people. Good combination it is. A projectile is projected at 30 degree from horizontal with initial velocity 40 meter per second. The velocity of the projectile at t is equals to 2 seconds from the start will be. After 2 seconds means. Okay. Projectile is projected at 30 degree. Initial velocity is 40 meter per second. If I write the velocity along x-axis, that is always same. What is that? U cos theta. If I write velocity along y-axis, that is u sin theta minus gt. This is how we wrote the equation along x-axis and y-axis. You have to put the values. U cos theta. What is u? U is my 40 into cos of 30 degree. That comes out to be 20 root 3. Okay. U sin theta 40 into sin 30 minus g into t. T is my 2 second. G is 10 into 2. This comes out to be 0 because sin theta is 1 by 2. 20 minus 20 is 0. Only the particle is moving along x-axis and the velocity is 20 root 3. Sir, in which batch you are teaching? I was there in Arjuna JEE, okay. So, right, in English. Right now, I am not there in that batch. So, I am on a different vertical right now. Let us do this question quickly. Projectile is projected at 30 degree from horizontal. Initial velocity is 40 meter per second. The velocity of the projectile at, sorry, this is the same question. Sorry for this. Same question it is again. Now, till now we did ground to ground projectile. Ground to ground projectile means you are projecting from the particle from the ground, it is landing on the ground, you are finding different variables. Now let us take a projectile from a certain height. You are throwing from a certain height. You can consider initially it is projected horizontally, throwing horizontally. This is your x-axis, this is the y-axis. Now the particle is only having velocity along x-axis initially. After some time it will gain velocity along y-axis with the time, okay, with the time. Now here what can be asked? What will be this range? How much time it will take to reach the ground? Or at any instant, what will be the velocity? What will be the angle when it strikes the ground? Okay, all these kind of things it can ask. First of all, let us find the time of flight in this case. Time of flight. It is falling a distance h along y-axis. So, I am writing the equation of motion first initially, first only along y-axis. Only along y-axis, what is the displacement? It is coming from here to here. What is the displacement? In the downward direction. What is that? Minus h. I am using s is equals to ut plus half at square along x-axis, along y-axis. What is this? Minus h, minus h. What is the initial velocity along y-axis? 0 plus half acceleration is minus g into t square. T is my time of flight. From here, I got the time of flight as root of 2h by g. Now, the interesting thing is here is it takes the same time whether you throw a particle horizontally or you just drop a particle like this. They will reach the ground in same time. Why like this? Why same time? Because motion along y-axis is same. If the initial velocity along y-axis is 0, they will reach the ground in same time. You are just giving velocity horizontally. It will not change your motion along y-axis. Motion along y-axis will remain the same. Sir, please come to our batch. Nirushak, in which batch you are? Which batch you are right now? Okay, so this is my time of flight. Then what will be the range? This range r. The distance it is traveling along x-axis, that is the range. In what time? In time of flight. Okay, so range will be equal to time of flight into the velocity along x-axis. Isn't it? Range is the distance along x-axis it covers. So the velocity along x-axis into the time of flight. What is velocity along x-axis? That is the initial velocity u. It is throwing horizontally. That is u. U into root of 2h by g. This is my range. Okay. Now, this was the condition when you are throwing it horizontally. What will change if you are throwing the particle at a certain angle? Above the horizontal or at a certain angle below the horizontal? How the things will change? Okay, let us take, this is h. You are throwing a particle now at some angle theta with the vertical. Then the particle will go like this and will come. Now you tell what will be the time of flight. Then you tell how much will be the horizontal range, or something else can also be asked like this. Arjuna JEE, which you taught up to motion in a plane. Now the problem is that was a call of the management that like I left Arjuna JEE batch. Okay, so that was not from my side. I already mentioned that. So management decided and I had to leave that. So this is, the change was decided by them. So guys, it's not from my side. Okay. Now, what will be this range? If you have to find what will be time of flight, do the same things. Only thing is, now you are having some initial velocity along y-axis also and along x-axis also. Let us take, this is u, so this will be u cos theta, vertical u sin theta. When you write along y-axis, when it will reach the ground. So see the motion along y-axis and use the equation s is equals to ut plus half at square along y-axis. What is the displacement? Displacement is minus h. Particle is coming from this height to this height. So total displacement along y-axis is minus h is equal to, what is the initial velocity along y-axis? U sin theta into the time of flight plus half, acceleration is minus g into time of flight square. Now here you are getting a quadratic equation. Air resistance, I'm not taking here as of now. Okay, air resistance, we took the air resistance case in 1D motion. Okay, in 2D air resistance we are not considering as of now here. Okay, if it is specifically mentioned then you have to consider, but considering that air resistance in 2D is not that straightforward. Okay, so that then you have to use different methods. Anyways, we are not considering that condition here. Nirushek, that is not possible. Okay, as I mentioned, that call is not from my side, so it's not. I am not the one who can decide this. So this is how we write the equation. Now here, this is a quadratic equation. We can solve for time of flight in this case easily. Okay, and what will be the range? What will be this horizontal range in this case? So horizontal range will be just the time of flight into the horizontal velocity. Horizontal velocity is u cos theta into time of flight, Tf. That's all. I got the range. Yeah, there can be, the particle can be, projected at certain angle below the horizontal. Then things will change. Below the horizontal, then your initial velocity along y-axis will become minus u sin theta. I'm talking about this case. The particle is thrown below the horizontal like this. It will go somewhat like this. If this angle, let us take this angle is theta, so initial velocity along x-axis will be u cos theta. Along y-axis, it will be minus u sin theta, this component u sin theta. Okay, because it is in the downward, that will be minus u sin theta. So here I'll write just minus u sin theta, rest of the things will remain the same. Question. A body of mass m thrown horizontally with velocity v from the top of a tower of height h touches the ground at a distance of 100 meter from the foot of the tower. Body of mass m is thrown horizontally with velocity v, means like this. It goes like this. The height is given as h. Okay. Then touches the ground at a distance 100 meter from the foot of the tower. This is 100 meter. Then a body of mass 2m thrown at velocity v by 2 from the top of the tower of height 4h will touch the ground at distance how much? Means next case, we are having a very high tower. Here the height is 4h. Now you are throwing the particle from here. Okay, and you have to find at what distance it will land. Change of mass will not make any change, whether you project a 2m mass, 4m mass or m mass, that will not make any change in the motion. Okay. How to find this, by the way? Range is time of flight into the horizontal velocity. Horizontal velocity into time of flight. What is time of flight? Root of 2h by g. That is the time of flight. Here we are projecting with velocity v by 2, not with the same velocity. Here if I write this range, let us take that as r dash, that will be horizontal velocity into the time of flight is 2h by g. What will be h? H is 4h here. This is v into root 2h by g. This is v by 2 into root of 2 into 4h by g. When you take 4 out, this 2 will get cancelled. Now these two are same things. That r dash is equal to r only. It will be 200 meter only. Sorry, 200, not 200, 100. This is 100 now. So this is also 100. It will remain the same. Exactly the same. Where it was, touches the ground at a distance of 100. Yeah, both are 100 in this case. Okay. Can you give your phone number? Not in the live class. Sorry for this. Okay. Now, projectile on inclined plane. Now, when we are projecting a particle on the inclined plane, then you observe the motion in along the inclined plane and perpendicular to the inclined plane. Write the equation separately, the same way we wrote for general projectile motion. So here, you can take your this as your x-axis. Just a second. This as your x-axis. and this as your y-axis. X-axis, y-axis. You are projecting with some velocity u at an angle theta. Now you take the x component u cos theta. This theta is with the horizontal, by the way. So this theta will be theta minus alpha. This angle will be theta minus alpha. So it will be u cos of theta minus alpha. Vertical y component will be u sin of theta minus alpha. That way. So this will be u cos theta minus alpha. The vertical will be u sin theta minus alpha. Okay. These are the velocities. Now take the acceleration component also. Acceleration is in the downward direction, g. This component will be g sin alpha. This component will be g cos alpha. Now write the motion along x-axis, along y-axis. Initial velocity along x-axis, u cos of theta minus alpha. Initial velocity along y-axis, u sin of theta minus alpha. Acceleration along x-axis, minus g sin alpha. Acceleration along y-axis, minus g cos of alpha. You know the initial velocity, you know the accelerations, write the equations. Okay. Okay. Nirushek. Okay, so we know the velocity acceleration along x-axis, we know the velocity acceleration along y-axis, y-axis and x-axis. Then we can write the equation whatever we have to find: time of the maximum height from the inclined plane, time of flight, the range. But yes, here because accelerations are along both the axes, so equations are a bit, you can say, lengthy. Not complicated, but lengthy, a bit lengthy. In case of projectile on an inclined plane, if we talk about the maximum range, repeat, my way, my life official. So please mention which portion you want me to repeat. Which portion you want me to repeat, then I'll repeat that. You should write, na sir, repeat this, then I'll repeat that particular one. Acceleration and these things are clear. I just took the component. G is in the downward direction. If you take this component, that will be g sin alpha. Other component will be g cos alpha. Just you know how to take the component of a vector. Velocity, this is velocity. Take the horizontal component, then take the vertical component. Here, this I am taking my x-axis. This I am taking my y-axis. Okay, so I am taking components along those two axes. Then you write separately. If you have to write any time t, what will be the velocity along y-axis? So use relation v is equals to u plus at, vy is equals to uy plus ay into t. So vy is u sin of theta minus alpha is equals to, sorry, vy we have to find. Vy is equals to uy, initial velocity along y, that is u sin of theta minus alpha, u sin of theta minus alpha plus ay is minus g cos alpha. So minus g cos alpha into t. Put the equation along y-axis, velocity at any time t. You can write y coordinate also. S is equals to ut plus half at square. So y is equals to uyt plus half ay into t square. So y is equals to uy is u sin theta minus alpha, sin of theta minus alpha minus half ay was minus of g cos alpha. So it will be g cos alpha into t square. That's all. Same thing you do along your x-axis. Same thing. Observe the motion. Okay. I was talking about the maximum range case in case of motion on an inclined plane. If an inclined plane is at an angle of, let us take alpha. At what angle you should project your particle such that your range on the inclined plane will be maximum. For that, you have to see what is your available angle, half of the available angle. Like for the ground to ground projectile, you can project from 0 to 90 at any angle. Okay, in one particular direction I am talking about. So 0 to 90, half of that 45. Therefore, at 45 degree, it was coming out to be the maximum range. Similarly, here, if you have to project for the maximum range condition, this is your total available angle, that is 90 minus alpha. Okay, half of the available angle will give you the maximum range. Half of the available angle. How much that is? 90 minus alpha by 2. Okay, so if the particle is projected at this angle with the inclined plane, how much? 90 minus alpha by 2. It will give you the maximum range. How to get it, sir? How to prove it? To prove this, you write your range first. Huh? You write your range first and then differentiate that. You will get the maximum range when the angle is half of this available angle. The range maximum at 45 degree, na? Range is maximum at 45 degree for the ground to ground projectile. When you are projecting on an inclined plane, that time it will not be maximum at 45 degree. Then it will be half of the available angle. Available angle is 90 minus the angle of the inclined plane, half of that. You project at that angle with the inclined plane, it will reach the maximum range there. Okay. Are you leaving PW after this? No, I am not leaving PW. Okay, I am on a different vertical. Okay. Okay, let us do this question. Find range of projectile on the inclined plane which is projected perpendicular to the inclined plane with velocity 20 meter per second. It means you are throwing it perpendicularly. What will be the range? What is this? How to find this? How to find this? I have to find this range. You can observe the motion separately along this. You can take as x-axis. This you can take as y-axis. You know the initial velocity. You can find the time of flight. Then you can find how much distance it will cover along x-axis in that time of flight. Sir, हिंदी में पढ़ाओ. हिंदी में पढ़ा सकते हैं, but this channel name is PWJ English. Okay, so I will be restricting myself in English only. Madhul, I mentioned previously that this was the management decision. This decision of leaving Arjuna JEE English batch was not from my side. Okay, so that was not my decision. I was told to leave that, so therefore I had to leave that. So this was a management call. Okay, let us find R here. First of all, along, if you see, I'm making my x-axis and y-axis here first. This I'm taking as my x-axis and this I'm taking as my y-axis. This is my y-axis, this is my x-axis. This is my x-axis. Okay, along y-axis, if you see, what is the acceleration? Okay, g, this is g sine theta, this is my g cos of theta. Theta is my 37 degree. Okay, g sine theta, g cos theta, like this. Previously, just a second. Now, along y-axis, if I see, what is the acceleration? Along y-axis, that is minus g cos of alpha. Okay, minus g cos of, previously that this angle was alpha, na? Let me write alpha to avoid confusion. Alpha means this 37 degree only I am calling this, or you can write just as 37 degree. So let me write it specifically 37 here, cos 37, 37. Put it g cos 37. What is the initial velocity along y-axis? That is my 20 meter per second. So if you write the velocity along y-axis, v is equals to u plus at. This equation I am using. V is equals to uy. What is uy? Uy is 20. Okay, plus ay into t, like that. You can write the velocity. Plus ay. What is ay? Ay is minus g cos 37 into t. Like this you can write. Okay, now you write how your y coordinate changes with the time. S is equals to ut plus half a t square. S is equals to u, initial velocity along y axis, that is 20, into t plus half. So minus half g cos 37 half a into t square. By the way, I don't need velocity along y-axis. This is not needed for this particular question. I just need my position. So I am just writing this equation. When the particle goes like this, comes back here, what is y? Y is 0. Y is 0. Put y is 0. 20t minus half g cos 37 t square. From there, you will get your time when it will come back. Just a second. So you will get your time when it will come back. So t is equals to 0, y is 0, and at t is equals to 20 into 2 by g cos 37. This becomes my time of flight. I got my time of flight. Okay, I got my time of flight. In this time, how much distance it will cover along x-axis? Can I find that? Yes, easily. Now observe the motion along x-axis. Along x-axis, initial velocity is 0. I am using s is equals to ut plus half at square along x-axis. I am writing this only along x-axis. What is s? I need this displacement along x-axis. Okay, you can write that r is equals to initial velocity along x-axis 0 because it is projected vertically 0, plus half acceleration along x-axis is g sin 37 into time of flight square. Time of flight is this. Put it here. Put this time of flight from here in this equation and you will get what is value of r. How is IIT Delhi Abu Dhabi? Actually, like IIT Delhi is IIT Delhi. Okay, so if that is an extension of that there, but certainly that quality will not be there, nah. It's just an extension. Will take some time. Sir, where will we listen your future lectures? Future lectures will not be there actually online. Okay. Sir, why no class 12th backlog in 2 weeks? I don't know. It's like we don't plan these things. The management plan. It's their call. Sir, please tell me how take 20, not 20 cos of. Because it is projected vertically. It is not at some angle. If it would be some angle, then I will be taking cos theta or sin theta. Na? If it is 20 along y-axis, so velocity along y-axis is just 20. Velocity along y-axis initially is just 20. It is projected along y-axis only. Arohi Kumari. Hello, Arohi. Okay, so you can just do the calculations here and you will get your answer. Radius of curvature. In projectile motion, finding radius of curvature is also many times asked. What is basically radius of curvature? You will understand that in circular motion. Okay. In circular motion, you know there are two types of accelerations. One is the acceleration along y-axis. One is the acceleration along center towards the center, that is centripetal acceleration. Another is the tangential acceleration. Your centripetal acceleration is responsible for changing the direction. Your tangential acceleration is responsible for changing the magnitude of the velocity. These two accelerations are there. So, my centripetal acceleration is v square by r. This formula we have derived in the lecture in circular motion. Okay, I'll derive it today also. V square by r. From here I can say radius is V square by a centripetal. This is my radius of curvature. If the particle is moving uniformly or maybe non-uniformly in circular motion, there the radius of curvature is just the radius of that circle. आप थोड़ा हिंदी में पढ़ाइए प्लीज, उत्कर्ष सिंह। उत्कर्ष सिंह दिस चैनल, ये जो चैनल है ये PWJEE इंग्लिश है, तो इसलिए यहाँ पे हम केवल इंग्लिश में पढ़ाते हैं, ठीक है? ओके उत्कर्ष, तो ये प्लेटफॉर्म केवल और केवल इंग्लिश वाले स्टूडेंट्स के लिए है, तो इसलिए मैं इंग्लिश में पढ़ा रहा हूँ यहाँ पे। ओके radius of curvature. Now in circular motion, the radius of curvature is equals to radius of the circle. But in projectile motion, let us take, you are projecting a particle like this. So the particle is going like this. At any instant, if you ask, let us take, sir, here, what is the radius? What is the radius of curvature? Means at this instant, the arc on which the particle is moving at that particular instant, that arc, what is the radius of that arc? Or if you ask, what is the radius of curvature at the maximum height? So at maximum height, at this point, this arc, so the circle will be somewhat like this. What will be this radius of curvature? That is being asked. So what we need basically is, you just find the centripetal acceleration there and write centripetal acceleration as V square by r. From there, r will be your radius of curvature. Fall in love with literature. Okay, you was that, huh? You, who is that? Just a second. Neru Sheikh. So fall in love literature was your name, huh? Now I got it. I got it. You were there. Can you have a Prayas JEE batch in English for next year? Anirudh Ritvik. We'll see. We don't know, like. So management will see which is needed, so accordingly they will have. Okay guys, so basically what we need is, I need the centripetal acceleration, means the acceleration that is towards center. If I find centripetal acceleration, I will put centripetal acceleration here. From there I can get radius of curvature. This thing I have to learn from here. Okay, okay. Now see carefully guys. Let us take, the particle is going somewhat like this. Going somewhat like this. At any instant here, the velocity is like this. At some angle, maybe alpha with the horizontal. Here, acceleration is in the downward direction g. Okay. The component of acceleration perpendicular to the velocity will be my centripetal acceleration. Okay. And the component of acceleration along the velocity will be the tangential acceleration, because we know centripetal acceleration is acceleration perpendicular to the velocity. Okay, this is g. I need this component. How much is that? How to find that? Can I find that? Is it possible to find it here? Yes. This is alpha. This will be 90 minus alpha. This will be alpha. If this is alpha, this will be g cos alpha. So my centripetal acceleration is basically g cos alpha. And g cos alpha I will write as v square by radius of curvature r. So I will say radius of curvature comes out to be v square by g cos of alpha. Okay. Can you talk with me after this live? Yes, we can talk. Okay, I hope you understood this radius of curvature. This radius of curvature topic is generally covered after you can say circular motion, okay, because centripetal acceleration, tangential acceleration, once you understand, then only you can cover that, otherwise you cannot cover. Radius of curvature, yeah, radius of curvature has to be covered after that. Okay, hey, why I am covering it here? Because I know this is a backlog. You have already covered motion and plane. Again, you are watching this, so I can cover this topic for you now. Therefore, I covered it. Next, relative motion. So projectile motion we have covered. Now let us talk about relative motion. So in relative motion means you are observing other particle with respect to the first particle. With respect to the first particle, or you are observing the first particle with respect to the other particle. Okay, so means what I am talking about is like actually motion is always relative. Okay, like again I am saying, if I ask you whether I am at rest or in motion, you cannot say, like somebody may say like I am at rest, but I will say I am at motion. Even I am standing here, but still I am at motion. I am standing on earth which is rotating around sun, okay, revolving around sun, rotating on its axis. How can I be at rest? Somebody, you can say in the yeah, sky, okay, out of you can say earth, there he may say the earth is moving, so this person is also moving. He may say I am at motion. But somebody who is standing near me, he will say I am at rest. So motion, somebody is at motion or at rest is actually relative. So motion is actually always relative. When we talk about the motion of a particle, the velocity of a car, the velocity of a bike, that is with respect to the ground. Always we give with respect to the ground. So when we say, let us take particle A, particle B, it is having some velocity VA, it is having some velocity VB. So if you sit on A and observe B, then you will see velocity of B with respect to A. If you sit on B, observe A, you will see velocity of A with respect to B. Okay, so it's the relative like that. So velocity of A with respect to B is velocity of A minus velocity of B. Okay, or if I say velocity of B with respect to A will be velocity of B minus velocity of A, like this. Clear? Similarly, if there are some accelerations of A and B also, so I can say acceleration of A with respect to B will be acceleration of A minus acceleration of B. If I say acceleration of B minus acceleration of B with respect to A, that will be acceleration of B minus acceleration of A. Or if positions are also given, then you can find the relative position of A with respect to B, like that. Or the displacement is given, you can find the relative displacement of A with respect to B, and then you can apply the equations of motion in relative frame. Just it's a change of frame. Okay, just it's a change of frame. Like now we are applying the motion with respect to ground. With respect to ground, the velocity is this. With respect to ground, the acceleration is this. With respect to ground, the position is this. Then we are writing the equation. If you change the frame of reference, then you write the equations with respect to that frame of reference. Where is the problem? Just simple. So with respect to that, you observe all the things then. Okay. Let us just a second. So here we specifically we are talking about relative motion in projectile. Okay. So when two particles are projected and then you observe the motion of one particle with respect to other, that will be straight line. because the relative acceleration there is 0. Okay. So in projectile motion, okay, let us take one particle is projected like this. Okay, you can take this particle. Another particle is projected like this. You can take this particle as 2, and then you are seeing the relative velocity, acceleration, and that thing. So I am saying that here relative acceleration will be 0. Both are having acceleration in the downward direction. So A relative will be 0. V relative will be constant. V relative will be constant because acceleration is 0, velocity will be constant. That is the logic. Okay. And if something is asked where the particle will collide, or those things you can very easily solve that way. Like let us take this angle is 30°. This velocity is 40 meter per second. This angle is 60°, and this velocity is v. At t is equal to 0, you are projecting this particle like this. And let us take it as mentioned that they will collide in air. Then you have to find what is the value of v. Find v if the particles collide. Okay, if the particle collide, you can observe just the motion along y-axis. Okay, observe the motion along y-axis. So along y-axis, if I observe the motion, when they will collide, where they will collide, I don't know. Let us take they collide something like this in air here. So just along y-axis, if I see their acceleration is same, yes, their acceleration is same. So their velocity has to be same. Then only they will reach the same height at same time. Otherwise, that is not possible. Relative motion along y-axis. Relative acceleration along y-axis is 0. They have to have the same velocity along y-axis. So to collide in air, I will say 40 sine 30 has to be equal to v sine 60. 40 into 1 by 2 is equals to v into root of 3 by 2. So v comes out to be 40 divided by root of 3. Clear? Okay, and what else? Okay, that's all. Let us, this example is enough. We are having another example here. A fighter jet is flying horizontally at a certain height with speed 200 meter per second. Okay. So the fighter jet is like this. It is flying at a certain height with velocity 200 meter per second. Okay. When it passes directly overhead an anti-aircraft gun. So here is your anti-aircraft gun. Okay. Here. A bullet is fired from the gun at an angle theta with the horizontal to hit the jet. So let us take this bullet is fired at an angle theta with the horizontal. This bullet goes like this and hits the jet here. When the jet will reach here, okay, so the bullet from here projected at an angle theta will go and hit the jet exactly like this. If the bullet speed is 400 meter per second, here the speed is 400 meter per second, then the value of theta will be, okay. Now you see the relative motion along x-axis. Along x-axis, they are covering the same distance? Yes, because along x-axis, both were having same x coordinate. When the bullet strikes here, they are having the same x coordinate. It means along x-axis, the displacement is same. Along x-axis, the acceleration same, 0. Okay, it means the velocity along x-axis has to be same.
Otherwise, they cannot strike. They have to have velocity along x-axis same. So I will say this horizontal velocity 200 is equal to this horizontal velocity, which is 400 cos theta. So I got 400 cos theta has to be equal to 200. So cos theta comes out to be 1 by 2. Means theta is equal to 60 degree. In the figure shown, two projectiles are fired simultaneously. What should be the initial speed of the left side projectile for the two projectile to hit in mid-air? They should have the same vertical component. They are having the same displacement along y-axis. Same displacement along y-axis in t. It means they have to have the same velocity along y-axis. Acceleration is same along y-axis. Okay, so I will say u sine 60 is equal to 20 sine 45. Easy. What's the time now? It's 7:20. Okay, let us continue for 10 more minutes, then we will take a break and then we'll continue from there. Relative velocity, relative motion. So in motion in a plane specifically, we will study two things. One is the river crossing, another is the rainman problem. Okay, for finding the relative velocity, finding the relative acceleration, relative displacement, that I have already mentioned. Now let us directly come to the river crossing problem. In river crossing problem, you know, a person is there, he can swim with certain velocity with respect to river. The river is also having certain velocity. Okay, then the resultant velocity will be the combination of the two velocities, and then you will find the things there what is asked. Sir, will you take more questions, sir? More question means like the topics which I am taking, I'll be taking questions on those topics. Amal, hi sir, I miss you. Hello Amal. Okay, so here we let us take, okay, here let us take, this is our river. Water is there in the river. The river is flowing towards right, okay, like this, V river. The river is flowing towards right like this with some velocity V river. There is a person here. Now you know the velocity of the person or separate sessions for it. Not separate session, okay, there will be not separate session. We are taking here only the questions. Whatever questions we will take for motion in plane, here itself we will take. So here the river is flowing towards the right with some velocity V river. A person is standing here at this point. The person is standing here. Now this person wants to cross the river. You know with what velocity the person can swim. Now with what velocity the person can swim, that velocity is in the still water. Okay, if the water is at rest, the person can swim with this velocity. It means that velocity is with respect to river. Velocity of person with respect to river. This will be known to us. So I say velocity of person with respect to river is velocity of person minus velocity of river. So the velocity of person will be the resultant of the two things, which this is what is the capacity of the man, okay, with which he can swim with respect to water, plus the V river. Like if the person is trying to swim in this direction, the river will, will add some horizontal component also, it will, go at some certain angle. So it will be the resultant of the two. Okay. We are taking a break and I am giving you a question. If you want to attempt that in the break, you can attempt that. Let us take that question on radius of curvature here. Find a particle. Okay, so let us write the question. A particle
is projected with velocity of 50 meter per second at uh, theta is equals to 60° with the horizontal find the radius of curvature of the particle at first maximum height, second after t is equals to 1 second, after t is equals to 1 second from projecting the particle. You can attempt these two questions. We are taking a break now. We'll be back at 7. What is the time here? 7:26. We'll be back at 7:40 p.m. Okay. 10 to 15 minutes break for you people. So if you have time now, energy, you can attempt this question. I'll solve this question after coming.
Okay, so we are back. We need to find the radius of curvature in this question at t is at the maximum height and after t is equals to 1 second. Okay. See, if I talk about maximum height case, the particle is going like this. At maximum height, it is just moving horizontally. At maximum height, it is just moving horizontally. With what velocity? U cos of theta at the maximum height. Okay. What is the acceleration? Acceleration is in the downward direction. What is the component of acceleration perpendicular to velocity? Means the centripetal acceleration, that is g only. At this instant, the centripetal acceleration is g only. A centripetal is equals to g in this case. That is equal to v square by r. What is v? U cos of theta. So g is equals to u cos of theta square by r. So radius of curvature comes out to be u square cos square theta by g. This is the radius of curvature. Okay, then let us do for the second part. Now here we can put the values and we can get the radius of curvature for this. Now let us find what will be the radius of curvature after t is equals to 1 second. After t is equals to 1 second or at t is equals to 1 second, what will be velocity? Horizontal velocity will be same. What is that? That is 50 cos of 60. 25. The vertical velocity, this is my Vx. Vertical velocity, that is u sin theta minus gt. U is 50, so 50 cos 60 minus 10 into the time is 1. So it is 25 root 3 minus 10. This is the y velocity, this is the x velocity. What is the angle in this particular case? Okay, means with the horizontal, the angle. Okay, so that will be Vy by Vx, simply 25 root 3 minus 10 divided by 25. With 5 you can cancel 5, 5, 2. So this is 5 root 3 minus 2 by 5. Okay, I got the angle. So the particle is somewhat moving at angle alpha, not theta, alpha. The g is downward. You need to take the perpendicular component of acceleration to the velocity. Okay, this angle is alpha, this is g cos of alpha. So you will say your g cos of alpha is equal to g cos of alpha is equal to your velocity v here, v square by r. There r will be equals to v square by g cos of alpha. Here calculations will be a bit difficult, by the way. What will be v there? How to find this velocity v? Initial velocity was u, this angle was theta. How to find this velocity v? Horizontal components will be same because along horizontal direction the velocity is not changing. So u cos of theta will be equals to v cos of alpha. U cos of theta will be equals to v cos of alpha. So I got my v as u cos theta by cos alpha. Put it there. Put it there. So this is u cos of theta by cos of alpha whole square by g cos of alpha. Okay, u is 50, cos theta, cos 60, that is alpha. How to find alpha? 10 alpha I got. You have to find cos alpha from there. Do some calculation. It is a lengthy question actually. This second part was a bit lengthy. Now calculations will be a bit more difficult in this case. I gave this question to make you understand the concept. Coming back to the river crossing here. So in river crossing, we are having velocity of the person with respect to river, the ability of the person with which he or she can swim. Then we actually want how the person, in which direction the person is swimming. For that, what we need? Velocity of person. The velocity of person is addition of the velocity of person with respect to river plus velocity of river. So in whatever direction, let us take the person is pointing its direction in this, pointing its velocity in this direction, you need to add that with velocity of river. Okay, the resultant of the two will be the velocity of person, like this. He can choose any angle, okay, according to how he want to swim, but resultantly he will move with the combination of these two velocity. Okay. Now let us talk about crossing the river in the minimum time. Crossing the river in minimum time. You are having a river like this, okay, and here is the person. Now when the person want to cross the river in minimum time, it means the person has to have a displacement along y-axis equal to the width. Means if I consider this direction as y-axis equal to the width of the river. In minimum time when he will be able to cover, for that condition he will be having its velocity along y-axis. Total velocity. Resultantly, he will not be moving along y-axis. Resultant, he will be moving at some angle. But for minimum time, he will be pointing its velocity perpendicular to the direction of river flow. So the angle between the vector A and B is asking this question. If you want to find the angle between two vectors, how to find? A dot B is equals to A into B cos theta. So cos theta will be equal to A dot B divided by magnitude of A into magnitude of B. That way you can write. Okay. In minimum condition, the velocity of person with respect to river will be in this direction and the velocity of river is in this direction. The person will be moving in a direction resultant like this. Huh? So the resultant of these two vectors, that will come somewhat like this and the person will reach somewhat here. Okay, let us take width of the river is W. Now if somebody asks you what is the time to cross? Time to cross will be the width divided by the velocity along y-axis. What is width? Width is W. W divided by velocity along y-axis, velocity of person with respect to river. That's all. थोड़ा हिंदी में भी एक्सप्लेन कीजिए अंकित। अंकित, ये जो चैनल है ये PW JEE इंग्लिश है, तो यहाँ पे केवल इंग्लिश में। हाँ, ओके। दिस इज द टाइम टू क्रॉस द रिवर। नाउ what is this distance? We call this distance as drift. Okay, so drift means the distance in along the river, okay, with which the person will be pushed by the river. Okay, so that is the drift. So drift, if I write, that will be equal to the horizontal velocity into the time, isn't it? Along horizontal direction I am writing the horizontal velocity into the time. So it will be the horizontal velocity is v river into the time. Time is W divided by velocity of person with respect to river. This is the minimum time case. Then zero drift. Condition. Zero drift condition means the person want to reach exactly at the opposite point. Exactly at the opposite point. This is my river. The person is starting from here. This is point A. And the person want to reach exactly point B. Now in which direction he should swim and how much time it will take? Okay. So you consider that the person is swimming in somewhat this direction at an angle theta. Okay. This is my velocity of person with respect to river. Now this vector plus velocity of a river, this is giving the resultant along this direction. This is the velocity of person. Okay. Somewhat he will say says that in the horizontal direction it will cancel out and in the vertical direction it will remain only. So in the horizontal direction to cancel out, so this horizontal component of velocity of person with respect to river, what that will be? The horizontal component, that will be velocity of person with respect to river sine theta. This should cancel this. Then only the person can move resultant in the y direction. So velocity of person with respect to river sine theta is equals to velocity of river. So I can say my sine theta comes out to be velocity of river divided by velocity of person with respect to river. So theta is equals to sine inverse of this. Now zero drift is only possible when your velocity of person with respect to river is greater than velocity of river. Sine theta has to be less than 1. Okay. So zero drift is only possible when velocity of person with respect to river is greater than velocity of river. This should be there. Okay. This should be there for zero drift. Okay. Now what is the time to cross? Velocity of person will be just the y component of this. If I take y component of velocity of person with respect to river, that will be velocity of person with respect to river cos theta. That will be my resultant velocity. Okay. So I can say velocity of person with respect to river cos theta is my velocity of person. Okay. So now how much time it will take to cross? Width divided by that velocity. So time to cross will be equal to width. What is that? W divided by velocity of person with respect to river cos theta. What is cos theta? Here I know sin theta. You can find cos theta and find it. Class is not completed. We are discussing. Okay. Okay. Then there can be like swimming along a particular direction. Swimming along a particular direction means, let us take, this is our river, okay, and here is the person, and the person should reach here at that point B. They will give you that this line is, let us take, making some angle 30 degree or maybe any angle, let us take alpha with the horizontal. Now the person should swim along this, means from A the person should reach directly B. Now in which direction he should swim? Okay. Sir, आपसे मुझे बात करना है. If you want to talk, then you can search my Instagram ID itje.sumit, okay, and then you can text me personally. I'll respond there. Okay. So my Instagram ID is itje.sumit. itje, sorry. This ID. You can search on Instagram. You can message me. I'll respond. Okay. the person should swim resultant in this direction. Resultant in this direction. So person will apply its own velocity somewhat like this. Somewhat like this. Let us take at an angle theta from here. This is velocity of person with respect to river. The velocity of river is in the horizontal direction. Velocity of river. A resultant of these two vector should come along AB. Then only the person will move along AB. Otherwise, the person will not be able to move along AB. Okay. The resultant of these two vectors should come along AB. Then only the person will move along AB. Okay. Now, the components of velocity perpendicular to AB should be 0. If a person has to move in a particular direction, the component of velocity perpendicular to that should be 0. Okay. Then only then he will be able to move in that particular direction. Let us take, if the person has to move along x-axis, the velocity along y-axis should be 0. Then only it will move along x-axis only. Okay. Or you can talk similarly about y-axis and other axis also. Okay. Sir, I still confusing on magnitude of vector. Can you explain it, sir, please? Magnitude of vector we will not talk here. Okay. Still not able to move on from you, sir, from Arjuna batch. Oh, Ritik, I also miss you people from Arjuna batch. What we can do? Okay. Welcome, Ritik, on this live. But I think you people have done these concepts nicely. So Ritik and Chetan, you are here. If you have covered these nicely, you can go also. You can practice your question, because I'm just revising those concepts for those students who are having backlogs. If you want to watch, it's your choice. If you have covered these topics, you can go and do some questions yourself. Okay. So the velocity of the resultant velocity perpendicular to this AB should be 0. Okay. So perpendicular to AB, the component of velocity of person with respect to river will be velocity of person with respect to river sine theta. This component will be velocity of person with respect to river sine theta. The component along this will be velocity of person with respect to river cos theta. Similarly, velocity of river perpendicular component will be velocity of river sine alpha. The component along this will be velocity of river cos alpha. Okay. This and this should cancel each other. They should cancel each other. They should cancel each other. Okay. Okay. So I'll say velocity of person with respect to river sine theta is equal to velocity of river sine alpha, and I got my value of sine theta. I got my value of sine. Then the time it takes to cross. Time will be the length of AB divided by this velocity total. The length of AB, that is my AB, divided by total velocity is velocity of person with respect to river cos theta plus velocity of river cos alpha. Velocity of person with respect to river cos theta plus velocity of river cos of alpha. That's all. You can write AB in terms of width also. Like if the width is given, this width is given W, okay, so that angle will be 90 minus alpha, so that will be W by sine of alpha. AB will be equal to W by sine of alpha, and then you will be able to substitute the values and solve if that is asked from you in the question. Okay, let us do some questions on this. The speed of a swimmer is 4 km per hour in still water. If the swimmer makes his strokes normal to the flow of the river of width 1 km, he reaches a point 750 meter down the stream on the opposite bank. The speed of the river of water is. The person is putting its velocity in this direction. This is the velocity of a river. This is velocity of person with respect to river. Resultant, the person is moving somewhat like this. He reaches here and this distance is 750 meter. Okay. The speed of the swimmer is this 4 km per hour. This is my 4 km per hour. What else is given to us? Width is 1 kilometer. This is 1 kilometer. So if I write time to cross, that will be this width, that is 1 kilometer, okay, divided by the speed, distance divided by the speed, which is 4 kilometer per hour. So this is the time to cross, 1 by 4 hour. Okay. This is my drift. Drift will be horizontal velocity into the time. That will be my drift. So drift, which is 750, is equals to V river into time. V river into 1 by 4 is equals to 750. This is 750 meters. Convert this to kilometer. Why? Because I am using velocity in kilometer per hour. Time I am using in hour, like that. 0.75. So V river is 0.75, that is my 3 by 4 into 4, that comes out to be 3 kilometer per hour. This is the speed of the person. 3 kilometer per hour. Okay. Minimum time condition it was. Next question. The stream of a river is flowing with speed this. A swimmer can swim at speed this. What should be the direction of swimmer with respect to flow of the river to cross the river? Straight. Straight means zero drift. For zero drift, we have sin theta is equals to velocity of river divided by velocity of person with respect to river. What is velocity of river? 2. What is velocity of person with respect to river? 4. This comes out to be 1 by 2. Theta comes out to be 30 degree. But this theta is not with the flow of the river. You have to find angle with the flow of the river. This theta was with the vertical. This is 30 degree, but this is 90. With the flow means this total angle 90 plus 30, 120. Okay. 90 plus 30 is 120. Next question. Oh, in this question, the person has to move along AB. A swimmer wants to cross the river from A to B. Line AB makes an angle 30 degree with the flow of the river. So this AB is making 30 degree with the flow of the river. Magnitude of velocity of swimmer is same as that of river. It means velocity of person with respect to river is given as velocity of river. That is given to us. Now what we need is, what is this angle theta? So velocity of river is this. This is velocity of person with respect to river. We know the perpendicular, the resultant velocity perpendicular to AB should come out to be 0. Okay, perpendicular to AB should come out to be 0. This is velocity of person with respect to river. So this is velocity of person with respect to river, sine of theta. This is velocity of river into sine of 30. They should cancel each other. It means they have to be equal. Velocity of person with respect to river, sine theta is equals to velocity of river, sine 30. These two are equal. This is getting cancelled. Theta comes out to be 30 degree. Okay. Next question. Oh, this is a different question. Here acceleration is there. Here some acceleration is there. It's not a constant velocity question. Let us read it out. Velocity of a river with respect to ground is given v naught. Width of the river is D. Okay, so this is my river. Width of the river is D. Okay, velocity of a river with respect to ground is V naught, means the river is flowing in this direction with V naught. Okay, a swimmer swims with respect to water perpendicular to the current. Okay, the swimmer is having its velocity in this direction. This is velocity of person with respect to river. With acceleration a is equals to 2t, where t is time starting from rest. Okay, this is my acceleration a is equals to 2t in this direction. You can write velocity in that direction at any time. Okay, then the equation of trajectory, how x will vary, how y will vary. Now see here carefully. See here, I am taking this as my x-axis and this as my y-axis. How x will vary and how y will vary? If I write x, what will be x at any time t? Horizontal velocity is v naught into the time. That will be x at any time t. Okay. What will be y at any time t? It is moving along y-axis like this. Okay. What will be y at any time t? Acceleration is given along y. So ay is equals to 2t. So ay you can write as dvy by dt. This is my 2t. So vy from here will be equal to t square. Okay, when you take dt on the other side, integrate, it will become t square by 2. It is t square. What is y then? You write dy by dt is t square. Okay, so dy is equal to t square. dt, integrate that, so it will become t cube by 3. So y is t cube by 3. X is v naught into t. Okay, replace it. What is t from here? X by v naught. Put it here. Y is equal to x cube by v naught cube into 3. First equation is coming. Sir, can you give motivation? We have discussed so many things in the class, but not in this live class. Okay. Nirushek, huh? That Nirushek, not in the class. Okay, now let us talk about Rainman problem. Here, rain is falling at some angle. The person is running on the ground. So, the velocity the person will see will be different than what is the velocity of the rain. That will be different. Huh? So, I will say velocity of rain with respect to man. This is the velocity the man will see actually. With respect to him, the velocity the man will see will be the velocity of rain with respect to man. So you will write velocity of rain with respect to man as velocity of rain minus velocity of man. Doesn't matter how the rain is falling. Let us take, this is the person here. The rain is falling like this at some angle. This is the velocity of rain. Now this person is running on the ground with velocity of man. So the velocity he will see will be velocity of rain minus velocity of man. This is minus velocity of man vector. Minus means opposite. Now, resultant of these two vectors will come somewhat like this. This will be the velocity this man will observe. Okay. Clear? This will be the velocity this man will observe, and then you can find the angle with the vertical at which he has to hold the umbrella or whatever is asked in the question. Let us do a question on this. When a car is at rest, its driver sees raindrops falling on it vertically. It means rain is falling vertically. When the car is at rest, the rain is falling vertically. Means what? Rain is falling vertically only. So, velocity of rain is in this direction. Okay. When driving the car with speed v, he sees raindrops are coming at an angle 60 degree from horizontal. Okay, so this is the car. When the car is moving with some velocity v, he sees that this is minus velocity of car. So resultant of the two will be somewhat like this. And he sees that comes at an angle 60 degree from the horizontal. This angle is 60 degree. So you can say your tan 60 is equal to, tan theta is equals to perpendicular divided by the base v. Next condition, on further increasing the speed from v to 1 plus beta v, this angle changes to 45 degree. Then this angle became 45 degree. So tan 45 is equal to v rain divided by, what is v? 1 plus beta into v. 1 plus beta to v. Okay. What is the value of beta? Now what you can do is you can divide these two equations. Tan 60 is root 3 is equals to v rain by v divided by 1 plus beta into v. V rain, v, v. 1 plus beta is equals to root 3. 1 plus beta is equals to root 3. Root 3 is 1.73. So beta comes out to be 0.73. Okay, clear? Just a second. Okay. Okay, so this was Rainman problem 1 question. This is another question. And this is a simple question actually, but let us try to solve it together. A boy is running on the horizontal road with speed 14 meter per second. So this person is running with 14 meter per second. Okay. Rain is falling at an angle 45 degree with the vertical. Rain is falling like this. This is the actual velocity of the rain. Okay. For boy, rain appears at an angle 37 degree as shown. Means with respect to boy, the rain appears at an angle 37 degree. Okay. Now what we need basically, what we need? Actual velocity of the rain. What is the velocity of rain? Velocity of rain means velocity of rain with respect to ground. That we need basically. Okay. So this is velocity of rain. The velocity of rain with respect to man will be velocity of rain minus velocity of man. Velocity of man is 14 meter per second towards right. So minus of this means opposite. Minus means opposite. Okay. So resultant of these two vectors is coming at an angle 37 degree with the vertical. Like this. This vector is giving a resultant at an angle 37 degree with the vertical. Then we need to find what is the length of this vector. Okay. Let us take the component here. Velocity of rain with respect to ground. This will be cos 45. Velocity of rain cos 45. And this will be velocity of rain sin 45. Okay. Then you see. This velocity of rain sin 45, this velocity of rain sin 45. Horizontal is 14 minus velocity of rain cos 45. This will be 14 minus velocity of rain cos 45. Okay. The resultant is coming at an angle of 37 degree. Now you can say tan 37 is equal to this base, which is 14 minus velocity of river cos 45 divided by this, which is velocity of river sin 45. Now you put the values and you can get what is velocity of river in this. Okay, easy, clear. This question you can solve as a part of your homework. We have done in this question in the class. Now, shortest distance between two bodies. So, questions like, you know, one particle is moving in this direction with this velocity, another particle is moving in another particular direction. What will be the shortest distance between them? So, shortest distance question, you need to observe the other particle with respect to the first one, and then see how that other particle will move, and then take the shortest distance. Means, let us take a simple example I am giving you. Let us take, this is point A, particle A, this is particle B. Particle A is moving in this direction, particle B is moving in this direction with some velocity VA, VB. Now you need what is the velocity of B with respect to A. Okay, what is the velocity of B with respect to A? Basically, yeah, these distance will be also given to you. Let us take this distance is some y naught, this distance is some x naught. You need to find the shortest distance between them. Now, when they will move, okay, when and at what particular instant of time that shortest distance will occur, and like that, those type of questions. So, what you need to do is observe the one particle with respect to other. Let us observe A with respect to B. So, A with respect to B means velocity of A minus velocity of B. This is minus velocity of B. Okay. Now, you are sitting on B. Now, you are sitting on B. So, A will move somewhat like this in this direction. Resultant of these two will be like this. When the shortest distance will happen, shortest distance of this path of A from B will be this perpendicular distance. So, you just have to find this perpendicular distance, that will be the shortest distance. D minimum. This is what we need. This is what we are interested in. Okay. Let us do this question. This JEE main question. A ship is sailing towards northeast with velocity this. Okay. Where I cap points east and J cap point north. Ship B is at a distance of 80 km east, 150 km north of ship A and is sailing towards this direction. What will be the minimum distance of B from A? In this question, a lot of calculation is needed. Okay, so what we will do is we will understand the method. I will leave calculation for you people. You have to do calculation from yourself. I will tell you the method, what is happening here, by the way. Ship B is at a distance of 80 km east and 150 km north of A. Let us take here ship A is there and here ship B will be. 80 km east, this is 80 km and 150 km north. This is 150 km. Okay. Of A and is sailing towards west at 10 km per hour. A is sailing towards west. No, B is sailing towards west with 10 km per hour. This is velocity of B, 10 km per hour. What is the velocity of A? 30 I cap plus 50 J cap. 30 I cap, 50 J cap. This is the velocity of A. This is the velocity of B. These are the distance. Now you need to find when this distance will be minimum. And what that minimum distance will. Basically, we need time here in this case. But generally, what is that minimum distance? When this distance will be minimum, that we need to find. Okay. Let us understand. What we will do is, we will observe motion of B with respect to A in this case. Let us observe motion of B with respect to A. Huh? So, observe B with respect to A means velocity of B minus velocity of A. Velocity of B minus velocity of A. When you do the minus means do the vector opposite and add. 10 plus 30 in this direction, that will become 40. Okay, so that will become 40 in this direction. So this is 40. Okay, and along y direction it was having plus 50. So here it will be 50 in this direction. So this is velocity of B with respect to A now. A is my here. So I am standing on A now. So I am standing on A means A is at rest now, and now I am seeing motion of B with respect to A. So B will be passing somewhat like this. This distance is 80 kilometers. Now see carefully in this. How much is this angle? You can take this angle, or how much is this angle? You can take that angle maybe as alpha. Okay, take that angle as alpha. You can say 10 alpha is equals to 80 divided by 15. 10 alpha is equal to 80 divided by 150. Okay, how the particle will move resultantly? These are the two components of the velocity. The resultant, you can say velocity will be somewhat like this. How much that angle of the resultant velocity will be? You can take that angle to be theta. So my 10 theta is equal to 10 theta. This angle is theta. 40 divided by 50 means 4 by 5. This was 8 by 15. 8 by 15. This is my theta. Okay, so resultantly this particle will be moving somewhat, means that ship B will be moving somewhat like this with respect to A. The minimum distance will be this perpendicular. This perpendicular. Okay, now you see I can find the time. How I can find the time? First of all, I need this angle. How much is this angle? Total was theta. This is alpha. This is theta minus alpha. This is theta minus alpha. And I know this distance. I know this distance. How much is this distance? This is under root of 80 square plus 150 square. Okay. Then what will be this distance? This cos of theta minus alpha. So this distance will be under root of 80 square plus 150 square into cos of theta minus alpha. Okay, I got this distance divided by this velocity. How much is this velocity? Under root of 40 square plus 50 square. This will be the time. I need this basically. Okay, now the thing is, how to find cos of theta minus alpha? You know 10 alpha, you know 10 theta. You can find 10 of alpha minus theta. Yes, you can find theta minus alpha. Yes, you can find. From there you can find cos of theta minus alpha. Okay, so I'll say 10 of theta minus alpha will be equal to 10 of theta minus 10 of alpha upon 1 minus 10 theta 10 alpha. This equation we know. Now in this equation you put 10 alpha, you put 10 theta, you will get 10 of alpha theta minus alpha. Once you get 10 of theta minus alpha, then you put cos of theta minus alpha. Find cos of theta minus alpha, put here, do the calculation, you will get the value. In this question, yes, we are having a bit more calculations, but this is the method to solve this. Okay. Now let us relative motion between two projectiles I have discussed. Okay, so I am not taking this. So we have discussed this previously. Now coming to the circular motion. Till now we were talking about the motion in a plane along x-axis and along y-axis. Now our particle is moving in a circular motion. Moving in a circular motion means the particle is moving something like this. At any instant, how we define the position here? We define the position with the angle of the particle. If the particle is here, I will say this is my position. So I will denote the position with theta. This we say as my angular position. So my angular position here is my theta. Angular displacement will be change in the angular position, because displacement is change in the position. Similarly, angular position will be change in the angular position. Initially, the particle was somewhat here at some angle theta 1, then the particle is somewhat here at some angle theta 2. Change in the angular position is this, theta 2 minus theta 1, simple. So angular displacement is theta 2 minus theta 1. What is the direction of angular displacement? Use right hand thumb rule. The particle is moving like this. Okay. Close your fingers in this direction. Direction of thumb out of the plane. That is the direction of theta 2 minus theta 1. Now angular velocity. What is velocity? Velocity is rate of change of position. So angular velocity will be rate of change of angular position. Simple. Okay. So angular velocity which we call as or denote with omega, okay, that is rate of change of angular position, d theta by dt. If average angular velocity is asked, then you write delta theta by delta t. Average angular velocity. Omega average. So that will be angular displacement divided by time interval. Theta 2 minus theta 1 upon t2 minus t1. Okay. Now, angular acceleration alpha. What is angular acceleration? Rate of change of angular velocity. Simply, rate of change of angular velocity. The way we have acceleration, acceleration is rate of change of velocity. Similarly, angular acceleration is rate of change of angular velocity. And if we divide and multiply with the d theta, this will also become omega d omega by d theta. Like we write acceleration a as v du by dx. Similarly, we can write alpha as omega by d theta. Now let us solve some questions on this. A particle is moving on circular path of radius 5 meter. Its time dependence angular position is this. So this is how the angular position is varying. What we need? Angular displacement in first 3 seconds. So find how much is the change in the angular position in first 3 seconds. Then average angular velocity after first 3 seconds. Divide that with time interval. Angular velocity, differentiate that. Angular acceleration, again differentiate angular velocity. Let us do it. Angular displacement in first 3 seconds. So first 3 seconds, first I need theta at t is equals to 0. What that will be? This is my initial angular position. Put t is equals to 0, that is 0. Now theta 2 at t is equals to 3 seconds. Put t is equals to 3 here. So 3 cube by 3 minus t square divided by 2. What it is? This is 9 minus 9 by 2. So this is 4.5. Now angular displacement will be equal to theta 2 minus theta 1. That comes out to be 4.5. So this is 4.5. This I got. Average angular velocity, angular displacement divided by time interval. So angular displacement divided by the time interval. What is the time interval? 3. So this comes out to be how much it is? 1.5. 1.5. Okay. So this comes out to be 1.5. Unit will be radian per second. Then angular velocity at t is equal to 2 seconds, means I need the instantaneous one here. So d theta by dt. This is my omega. Differentiate it, it will become 3t square, differentiation of t cube. Okay. So that will be t square minus t square differentiation will be 2t by 2 t. So t square minus t, like this. Now put t is equal to 2 here. So this is 2 square minus 2. What is this? 4 minus 2. This comes out to be 2 radian per second. Okay. So this is 2 radian per second. Okay. Then angular acceleration. Angular acceleration you need. This is the angular velocity. Differentiate that. Alpha is equals to d omega by dt. So if you differentiate it, 2t minus 1. Now what is t? 2 second. Now put it here. 2 into 2 is 4 minus 1, 3. So this is 3 radian per second square. Okay. Next, if angular velocity of a particle depends upon theta like this, the angular acceleration will be here. Omega and theta is there. Omega and time is not there. Theta is there. So use the relation with theta there. Alpha is equals to omega d omega by d theta. Omega is theta square plus 2 theta. D by d theta of theta square plus 2 theta. That's all. It will become theta square plus 2 theta into its differentiation will be 2 theta plus 2. This is my alpha. When I need alpha at theta is equals to 1, put theta is equals to 1. So this will become 1 plus 2 into 2 plus 2. That comes out to be 12 radian per second square. Next. Here what is given? A ball is spun with angular acceleration this, t is time, alpha is in radian per second. At t is equals to 0, the ball has angular velocity of 10 radian per second. Angular position of is 4. The most approximate expression, not most appropriate, expression for angular position is, alpha is given to me. First write alpha as d omega by dt. So your d omega will be alpha dt integrated. What is the initial angular, alpha is this, this is alpha, this is alpha, this is the initial angular velocity, this is the initial angular velocity. Initial angular velocity is 10, final angular velocity omega. So this will become omega minus 10 is equals to integration of what is alpha? 6t square minus 2t, 6t square minus 2t dt. Time goes from 0 to t. When you integrate it, 6t cube by 3, so 2t cube minus 2 into t square by 2, so just t square. Omega comes out to be this plus 10 here. I got this omega. Now omega we will write as d theta by dt. Okay, then integrate it with proper limits. Okay, so I will write my d theta is equals to integration of 2t cube minus t square plus 10 dt, and time goes from angular position 4. Initial angular position was 4. So 4 to theta, 0 to t. Now put it. This will become theta minus 4 is equals to, if you integrate it, it will become 2t cube by 3, 2t 4 by 4, t to the power 4 by 4. So t to the power 4 by 2, it will become minus t cube by 3 plus 10t, and 4 will go on the other side plus 4. So what it is now? T cube by t to the power 4 by 2 minus t cube by 3 plus 10t plus 4. B option is coming here. Now let us find the relation between the linear velocity v and the angular velocity omega. Okay. Let us take the particle is moving somewhat like this. At some instant, it just traveled some, you can say, covered some angle d theta. Okay, what will be this length of this arc? Radius into that angle. Radius is r into d theta. So this is my arc length. You can say my ds. What will be the velocity? ds by dt. The distance it covered divided by the time, r d theta by dt. So I'm getting my velocity is equals to r d theta by dt is omega. This is the relation between, or you can say relation between the magnitudes of the two, velocity and the angular velocity. But I need the relation between the directions also. Okay, now let us see. Particle is somewhat here. What is the direction of velocity? This. Radius vector is outside always. Omega is, using right hand thumb rule, omega is perpendicular like this. Okay, now you see. If I do r cross omega, this is opposite of v. So if I do omega cross r, that is in the direction of v. So v comes out to be omega cross r vector. These two are always perpendicular. So the magnitude omega cross r, omega r sin theta is always 90. So that is always r omega. Okay, let us solve this question. Omega is given, r is given. We need to find the velocity. Velocity is omega cross r. It means you have to take the cross product of the two vectors, this and this one. Draw the matrix I cap, j cap, k cap. I need omega cross r. How we got omega cross r? We got like this from here. Okay, so omega, what is omega? This is omega. 3 minus 4, 1. R is 5 minus 6, 6. Now take the cross. I cap, you have to find the determinant of this. Okay, 6 into 4 minus 4, so minus 24 plus 6. Minus 24 plus 6. Then minus j cap, minus j cap. Okay, so 18 minus 5 plus k cap, that will be minus 18. Okay, minus 18 plus 20. So this comes out to be a minus 18 I cap minus 13 j cap plus 2 k cap. This we are getting minus 18 minus 13 and 2. Yes, taking cross product, you have to draw the matrix, then only you can find the determinant of that matrix. That is a standard method of taking the cross product. Now, uniform circular motion. Uniform circular motion means the speed is constant, not the velocity. Velocity can never be constant when the particle is moving in the circular motion. The speed is constant here. Means only the direction is changing. Magnitude of the velocity is not changing, only the direction of the velocity is changing. The particle is moving somewhat like this. Okay, let us take the particle is moving somewhat like this. Now, I want to find the acceleration. What is the acceleration? Is the acceleration 0 for uniform circular motion? No. Velocity is changing, direction is changing. It means acceleration is there. Acceleration is there. Velocity is changing. Means acceleration has to be there. Okay, velocity is changing. Let us take, you are considering a small fraction from here to here, a small angle, very small angle I am considering. I am making it a big to make you see it properly. Okay, this angle I am taking very small d theta. This was the initial velocity v, this is the final velocity v. Here initial, this is the final. The speed is same, direction is just changing. Okay, now I need, what is the acceleration? For that, I need first how much is the change in the velocity divided by the time interval, that I will get the acceleration. because I am taking very small portion, okay, here. So that acceleration will be my instantaneous acceleration only that I will get, not the average, because I am taking very small interval here, okay, very small arc here. Okay, this is my velocity v initial, this is my velocity v final. I need change final minus initial. My initial is this. This is the initial. The angle between the two will be d theta only. If this angle is d theta, the angle between the perpendiculars also will be d theta only. So this is angle d theta. So I am having this velocity v, and the angle between the two is d theta. I need final minus initial. Minus initial means you take the opposite and you take the resultant of these two vectors. This is 180 minus theta. The resultant of these two vectors you have to take. What will be the resultant of these two vectors? The resultant of these two vectors, v and v, what is the angle? 180 minus theta. 180 minus d theta, you can say. 180 minus d theta, like this. Huh? Okay. Now, two vectors at an angle of this. What will be the resultant magnitude? You can say under root of a square plus b square plus 2ab cos of theta. One 180 minus theta is equals to minus of cos theta. Cos of 180 minus theta is minus of cos theta. Huh? So it will become minus 2b square. Okay. 2ab cos theta. I am writing like this. If you are like clear, it is okay. Okay. So minus of this cos of d theta. Like this. Other way to write it is take the components. Okay, this is my you can say bisector here. That is my this half angle. How much this will be? This will be 90 minus d theta by 2. This angle will be 90 minus d theta by 2. Take the components along the bisector perpendicular to the bisector. Perpendicular to the bisector will get cancelled. Along the bisector will add. Okay. So this is my v sine of 90 minus d theta by 2. This will be v cos of 90 minus d theta by 2. Similarly, the component of this other v, this will be v sine of 90 minus d theta by 2. This will be v cos of 90 minus d theta by 2. The two horizontal components, this one and this one, they are cancelling. The along the bisector they are adding, and the resultant will be 2v cos of 90 minus d theta by 2. Cos 90 minus theta is sine theta. So sine of d theta by 2. If theta is very small, sine theta is nearly equals to theta. So you can just write d theta by 2 here. So it is 2v into d theta by 2. It is just v d theta. V d theta is the change in the velocity divided by the time it takes to cover, that I am taking as dt. This is my acceleration. What is the direction of this change? Direction of this change is towards the center. Direction of this change is towards the center. Now d theta by dt is equals to my omega. Okay, v is equals to r omega. Omega is v by r, so you can write this as v square by r or omega square r. And this acceleration is towards the center. Okay, because this resultant is coming along the bisector. This acceleration is towards the center. This we are calling as my centripetal acceleration. V square by r or omega square by omega square. Why tangential acceleration is not here? Because it is uniform circular motion. We are considering the speed is constant. The speed is not changing. Speed here is not changing. Speed is constant. So just we are getting the centripetal acceleration. Okay. A stone is tied to 180 centimeter long string at its end and its end is making 28 revolutions in horizontal circle every minute. The magnitude of acceleration of the stone is, this is a uniform circular motion. What is acceleration there? Centripetal acceleration. What is that? Omega square r or v square by r. Anything you can write. Let us write as omega square r. What is omega? It is making 28 revolutions every minute. It means in 1 second, 28 by 60 revolutions. In 1 second, 28 by 60 into 2 pi angle. It means this is my radian per second omega. I got my omega, put this omega here. Put this r. Where is my r? This is my r. Put this r here and get the acceleration. Simple, easy, straightforward. Now let us talk about non-uniform circular motion. Non-uniform circular motion means here speed is also changing. Speed is not constant. Speed is not constant. I was having V is equals to R omega. V is equals to R omega. If I say the change in the magnitude of the speed, okay, that is R into d omega by dt, that is my R alpha. This we are calling as the tangential acceleration, that is along the tangent. It can be in the direction of velocity or opposite to the direction of velocity depending upon whether your alpha is positive or negative. That's all. Okay, depending upon that. Centripetal acceleration will always be there. Centripetal acceleration will always be there. So, particle is moving somewhat like this in circular motion, like this. At any point, let us take the particle is here. It is having some velocity in this direction v. Yes, centripetal acceleration will be towards the center. Yes, tangential acceleration will be along the tangent. It may be perpendicular to the velocity or in the direction of velocity. Sorry, it may be opposite to the velocity or in the direction of velocity. It depends. Okay, this is my tangential acceleration. The resultant acceleration will be the resultant of these two vectors. So the net acceleration will be somewhat like this, A net. You can find the angle of the A net or you can find other things also. So if I say the magnitude of net, because these two are perpendicular to each other, it will be resultant of this A centripetal square plus A tangential square like this. You can find angle also here if you want. Let us do this question. A point moves along an arc of a circle of radius r. Its velocity depends upon the distance covered like this. This is how the velocity is depending. Find the angle alpha between vector of the total acceleration and the vector of the velocity as a function of s. So we need to find the velocity vector. Okay, we know that is in the tangential direction. So we need to find the total acceleration. How? Centripetal and tangential component of the two components, and you can find the total. Then you find the angle between the two. That's all. Okay, what is centripetal acceleration? V square by r. What is V? Alpha root s. So this comes out to be alpha square s by r. Clear? What is tangential acceleration? V dv by ds. Okay, what is V? Alpha root s. D by ds. Here it is alpha or A. I don't know. I think this is alpha. No, this is A actually. This is not alpha. Alpha is the angle. This is A. We write it again. Alpha is the angle. This is A. So this is A root S square by R. So this is A square S by R. A tangential. A tangential is V dV by ds. Okay. V dV by ds. What is V? A root S. Then d by ds of A root S. A you can take out. So that will become A square root S. Root S differentiation will be 1 by 2 root of S. So this root S is getting cancelled. It is A square by 2. Okay. This is my centripetal acceleration. This is my tangential acceleration. There is the circular motion, you can say. The velocity is in this direction. This is the centripetal acceleration. This is a different color. This is the tangential acceleration. Okay. The resultant acceleration will come somewhat like this. I need the angle between the vector of total acceleration and vector of velocity. This angle I need. Let us take that angle to be alpha. So I will say tan alpha is equal to perpendicular, that is my centripetal acceleration, divided by base. What is that? That is my tangential acceleration. Okay, A centripetal is A square S by R. Tangential is equals to A square by 2. It comes out to be 2S by R. This is how this angle alpha is changing. Rajiv Kulkarni, hello. Please come back to Arjuna JEE. That is not possible for me. Okay. Kusuma, okay, you are Kusuma. That is not possible for me because that is the management call and I cannot do anything about that actually. Now let us consider the case when alpha is equals to constant. Alpha is angular acceleration. If acceleration is constant, we know the three formulas for linear motion. S is equals to ut plus half at square. V is equals to u plus at. V square minus u square is equals to 2s. We know these three formulas when acceleration is constant. Now when alpha is constant, you can write these three formulas in the circular world. Okay. So S instead of S, the displacement, angular displacement, initial angular velocity plus half alpha t square. I got the formula. This V is equals to u plus at. Final angular velocity is equals to initial angular velocity plus alpha t. This it will become my final angular velocity square minus initial angular velocity square is equals to 2 into angular acceleration into the angular displacement delta theta. This is how we can use. Question. A body rotates with an angular speed of 16 rpm is uniformly accelerated to 1800 rpm in 10 seconds. Okay, the number of rotations made in the process. Okay, in this process, when your 16 rpm is changing to 18 rpm, how many rotations will be there? Okay, how to find this? Time is given to us. Initial and final, you can say angular velocity is given to us. My displacement is equals to initial velocity plus final velocity by 2. I know for uniformly you can say accelerated motion. Similarly, I can say my angular displacement will be initial angular velocity plus my final angular velocity divided by 2 into t. Sorry, I forgot it. Into the time. That's all. So here I am having revolutions per minute. If I put time in minute, then I will get revolutions directly. So So 1600 plus 1800 divided by 2 into the time in minutes, 10 seconds by 60. 1 by 6, huh? So what it is now? This is 2400 divided by 2 into 1 by 6. 6 into 2 is 12. 12 into 2. This comes out to be 200 revolutions. 200 revolutions. Okay, next question. A flywheel is accelerated uniformly from rest and rotate through 5 radian in first 3 seconds. Find the angle rotated by the flywheel in the next 3 seconds. In the next 3 seconds, it will be 15. How? You can take angular acceleration alpha as constant. So in first 3 seconds, total angular displacement theta 1 is half alpha into 3 square. In the next 3 seconds, theta 1 plus theta 2. Total angular displacement from 0 to 6 now. Okay, first 3 plus next 3. So total in the first 6 seconds will be half alpha into 6 square. Okay, what you need? You need theta 2, subtract the theta 1 there. So theta 2 will be equals to half alpha into 6 square minus 3 square. So it will be half alpha, 6 plus 3, 9, 6 minus 3, 3. Okay, so it is 3 square into 3. This part was 15. This is my 15. 15 in, sorry, not 15. Initially was 5 now. Sorry. This was my 5. This is my 5. This is 5 into 3, 15. So the answer comes out to be 15 radian. Okay. Okay. This question. Two particles A and B are moving on two concentric circles of radii r1 and r2. Okay. With angular speed omega. At t is equals to 0, their positions and directions of motion are shown in the figure. These are the condition at t is equals to 0. They are having same angular speed omega. Their relative velocity at pi by 2 omega. At pi by 2 omega, how much in time this, how much angle they will rotate? Theta is, delta theta is equals to constant angular velocity, na? Omega into t. Okay, pi by 2 omega into omega means 90 degree they will rotate. Okay, 90 degree will rotate. A will rotate by 90 degree and it will come here. What will be the velocity? R1 omega. B will rotate by 90 degree and it will come here. What will be the velocity? R2 omega. You need the relative velocity. Velocity of A minus velocity of B is equal to, what is that? What is velocity of A? Minus R1 omega I cap. Minus I cap is the direction. Huh? What is velocity of B? Minus R2 omega I cap. So plus R2 omega I cap. So this is R2 minus R1 omega I cap. R2 minus R1 omega I cap, that is option C. Okay, so these are the things that we need to cover as part of our backlog series in motion in a plane. Thank you all. We are ending this discussion here. Bye-bye.